Editing and Coding, Transforming Raw Data into Information, Chapter 19, Business Research Methods. So after studying this chapter, we should be able to know when a response is really an error and should be edited, appreciate coding of pure qualitative research, understand the way data are represented in a data file, understand the coding of structure responses including a dummy variable approach, and appreciate the way that technological advances have simplified the coding process. Now the starting example here is about coding what a person's face says. So understanding what respondents say or coding the data gathered from a survey represents a challenge that all businesses or business researchers face. But nowadays technological advances allow business researchers and give them a chance to collect and code data not based on what people say but what their face says. So body language is a key way that people communicate their thoughts and emotional states. And researchers have known from long that the power of nonverbal cues and response states and have thought to understand and how to capture this nonverbal communication. So the technology, sensor logic specialized in quantifying emotional responses through the facial coding tool is one example that researchers can use. And for sure in the future the ability to capture and to code physical data will become more and more commonplace, and will give the opportunity to speak, but without saying any word actually. So welcome to the future. Now the stages of data analysis, these are from raw data to intelligence, from data to information, how we can do it, editing, coding the data files, and then we have the analysis approach, different types of analysis, descriptive, univariate, bivariate, and multivariate analysis. Now a very common phrase that is used by the researcher is garbage in, garbage out. This refers to the idea that if data is collected improperly or coded incorrectly, your results are garbage, because that is what was entered into the data set to begin with. So researchers tend to be very anxious to begin data analysis once the fieldwork is complete. Now the raw data can be transformed into intelligence. However, raw data may not be in a form that lends itself well to analysis. Raw data are encoded just as respondent indicated. For an oral response, the raw data in the words of the respondents for a questionnaire response is the actual number checked in the number stores. And raw data will often also contain errors, both in the form of the respondent errors, but as well non-respondent errors. The respondent errors is a mistake made by the respondent. A non-respondent error is the mistake made by an interviewer or by a person responsible for creating an electronic data file representing the responses. Data integrity refers to the notion that the data file actually contains the information that the researcher promises the decision maker he or she would obtain. Data integrity extends to the fact that the data have been edited and properly coded so that they are useful to the decision maker. Any errors in the process, just as with the errors or shortcut in the interview process, will harm the integrity of the data. Editing. Fieldwork often produces data containing mistakes. Just think at a questionnaire and then in response, how long have you lived at your current address? And then the response is 30. Well, 30 what? The researcher has intended the response to be provided in years, But who knows, maybe you responded in months. Yeah, the possible respondent did respond not in years, maybe how many months? 30 months, not 30 years at the same address. So editing is the process of checking and adjusting data for omission, consistency, and legibility. In this way, the data becomes ready for analysis by a computer. So the editor's task is to check for errors and omissions on the questionnaires or other data collection forms. And then the editor sometimes needs to reconstruct the data. Well, in this case, the researchers can guess that the respondent entered the original questions in months instead of years. Field editing. Field supervisors often are responsible for conducting preliminary field editing on the same day as the interview. And then the field editing is used to identify technical omissions, such as a blank page on an interview form, or check the legibility of handwriting for open-ended responses, or clarify responses that are logically and conceptually inconsistent. Field editing is particularly useful when personal interviews have been used to gather data. And in these cases, a daily field edit allows the supervisor to deal with any problems quickly by asking the interviewers why it's still fresh in their mind, and then the interviewer may still be able to remember the interviews and clarify the issues. In-house editing. Although simultaneous field editing is highly desirable, in many situations, particularly with mail questionnaire, early reviewing of data is not always possible, and then in-house editing rigorously investigates the results of a data collection. The research supplier or research department normally has a centralized office staff perform the editing and the coding function. Do you have data integrity? Data integrity is essential to successful research and decision making. Sometimes it's a question of ethics, and data integrity can suffer when an interviewer or coder simply makes up data, or other things can occur that limit the data integrity. Data integrity can as well suffer simply because the data are edited or coded poorly. It's so important, consistent coding for companies that share or sell secondary data. And occupations need a common coding, just as do product classes, industries, and numerous other potential data values. But industries have standard codes, like the North American Industrial Classification System or the Standardized Industrial Classification. These are professional coders that have adopted Postal Service guidelines for coding things like states and addresses as well. So it's very important, like I said, for secondary data. Now, checking for consistency. Consider a situation in which a phone interviewer has been instructed to interview only registered voted in a state that requires voters to be at least 18 years old. If the editor's review a questionnaire indicates that the respondent was 70 years old, then the editor's task is to correct this mistake. But in this case, the respondents must be deleted because the individual should never have been considered as a sampling unit. So the sampling units should all be consistent with the defined purpose. So the editor as well should check for consistency within the data collection framework. For example, a survey on out shopping behavior, shopping in towns other than the one in which the person resides, might have a question like, in which of the following cities have you shopped for clothing during the last year? San Francisco, Sacramento, San Jose, Los Angeles, and other. Suppose the respondent checks Sacramento and San Francisco to the first question. But if the same respondent lists a store that has location only in Los Angeles in the second question, an error is indicated. Either the respondent failed to list Los Angeles in the first question or listed an erroneous store in the second question. So these answers are obviously inconsistent, but how exactly should they be dealt with? Taking action when response is obviously an error. What should the editor do? If solid evidence points to the fact that the respondent simply failed to check Los Angeles, then the response to the first question can be changed to indicate that the person shopped in that city as well. Los Angeles is not listed next to Sacramento or San Francisco, so it's unlikely that the respondent checked the wrong city inadvertently. So perhaps the question about the stores triggered a memory that did not come to the respondent when checking of the cities. So this seems quite possible, and if other question can as well point strongly to the fact that the respondent actually shopped at the store in Los Angeles, then the change should be made. Responses should be logically consistent, but the researcher should not jump to the conclusion that a change should be made at the first sight of an inconsistency. A change should only be made when multiple pieces of evidence exist that some response is in error and when the likely true response is obvious. Many surveys use filter or skip questions that direct the respondent to a specific set of questions, depending on how the filter question is answered. Common filter questions involving age, sex, home ownership, and product usage. And the survey might involve different questions for a homeowner than for some who does not own a home. Data record may sometimes contain data on variables that the respondent should never have been asked for. Editing technology. Nowadays, computer routines can check for inconsistency automatically. So for electronic questionnaires, rules can be entered that prevent inconsistent responses from ever being stored in the file used for data analysis. And these rules should represent the conservative judgment of a trained data analyst. Some online survey services can assist in providing this type of services, and different rules that can be pre-programmed to prevent many inconsistent responses. Editing for completeness. In some cases, the respondent may have answered only the second portion of a two-part question. It's a question like, let's say, does your organization have more than one computer network server? It's yes or no. If yes, how many? If the respondent checked neither yes nor no, but indicates 3 computer servers, the editor should change the first response to a yes, as long as the information doesn't indicate otherwise. So again, a computerized questionnaire may either not allow a response to the how many questions if someone checked yes, or require the respondent to go back to the previous question once he or she tried to enter a number for the how many question. Item non-response is the technical term for an unanswered question on an otherwise complete questionnaire. Missing data results from item non-response, and specific decision rules for handling this problem should be clearly outlined in the instructions. In many situations, the decision rule is to do nothing with the missing data and simply leave it blank. However, when relationship between two questions is important, such as that between a question about job satisfaction at one's pay, the editor may be tempted to insert a plug value. The decision rule may be to plug in an average or neutral value in each instance of the missing data. Leave the response blank because the question is so important. Plug in an alternate choice for the missing data. Randomly select an answer. The editor may just flip the coins yes or no, or the editor can input a missing value based on the respondent's choices for other questions. Many different techniques exist for inputting data, and some involve complex statistical estimation approach that use the available information to forecast the best guess for the missing responses. What about the missing data? Editor must decide whether an entire questionnaire is usable. If a questionnaire has too many missing answers, it may not be suitable for the planned data analysis. And the issue of non-response was a far larger concern in the past, when many statistical software programs require complete data for an analysis to take place. And some statistical routines may require that an entire sampling unit may be eliminated from analysis if a single response is missing. List-wide deletion. And today, most statistical programs accommodate an occasional missing response through the use of pairwise deletion. Pairwise deletion means that the data that the respondent did provide can still be used in a statistical analysis. And as a result, pairwise deletion produced a larger effective sample size than the listwise deletion. Facilitating the coding process. Another task an editor may face is rearranging the answers given to open-ended questions, such as may occur in a focus group interview. The respondent may have provided the answer to a subsequent question in his or her comments to an early open-ended questions. Because the respondent already had clearly identified the answer, the interviewer may not have asked the subsequent questions. And facilitating the coding process, while all the previously described editing activities will help coders, several editing procedures are designed specifically to simplify the coding process. The editors should check written responses for any stray marks. Respondents are often asked to circle responses. Sometimes a respondent may accidentally draw a circle that overlaps two numbers. And then the editor may be able to decide which number is the most accurate response and indicate that on the form. Don't know answers, how we can edit and tabulate these don't know answers. In many situations, respondents answer don't know. On the surface, this response seems to indicate unfamiliarity with subject matter of the questions. And then a legitimate don't know response is the same as no opinion. However, there may be reasons for this response other than the legitimate don't know. Maybe you are reluctant. A reluctant don't know is given when the respondent simply does not want to answer the specific questions. And in some situations, the editor can separate the legitimate don't knows, no opinion, from the others don't know. And then the editors may try to identify the meaning of the don't know answer from other data provided on the questionnaire. In structured questionnaires, the researcher has to decide whether to provide the respondent with a don't know or no opinion options. If neither of this is offered, then the respondent may simply choose not to answer when they honestly don't know how, or don't know what, or don't want to respond to a specific question. A computerized questionnaire can be set up to require a response for every question. Here, if a no opinion or don't know question is not made available, the result is a forced choice design. There are some pitfalls of editing. Subjectivity can enter into the editing process, and data editors should be intelligent, experienced, and objective. A systematic procedure for assessing the questionnaire should be developed by research analysts so that the editor has clearly defined decision rules to follow. Any inferences from an imputing missing value should be done in a manner that limits the chance for data editor subjectivity to influence the response. So the key issue here is consistency. The key issue is consistency, and data editors should treat all missing cases the same, not selectively based on how much they like the response they are seeing. Pre-testing edit. Editing questionnaire during the pre-test stage can prove very valuable. If the respondent answered to open-ended questions were longer than anticipated, everyone will benefit from a change to larger spaces for answers. and answers will be more legible because the writers have enough space. Answer will be more complete, and answer will be verbatim rather than summarized. This is pre-testing edit. Coding. Editing may be different from coding, which is the assignment of numerical scores of classifying symbols to previously edited data. Careful editing makes the coding job easier, and codes are meant to represent the meaning in the data. Assigning numerical symbols permit the transfer of data from questionnaire or interview forms to a computer, and codes often but not always are numerical symbols. However, they are more broadly defined as rules for interpreting, classifying, and recording data. In qualitative research, numbers are seldom used for codes. Coding qualitative data with words. These are unstructured qualitative responses from long interviews. The codes are usually words or phrases that represent themes. And in this example here shows a hermeneutic unit in which a qualitative researcher is applying a code to a text describing in details a respondent's reaction to several different glasses of wine. And the researcher is trying to understand in details what defines the wine drinking experience. So coding is facilitated by the use of qualitative software. After you read the text several times and applying a word counting routine, the researcher realized that appearance, the nose, the aroma, guessing, trying to guess what the wine will be like or what type of wine is in the glass are important themes. So a code is assigned to these categories. Same way, other codes are assigned as shown in the code in this window, and the density of columns shows how often a code is applied. And after considerable thought and questioning of the experience, the researchers build a network or a grounded theory that suggests how a wine may come to be associated with feelings of romance. So this theory is shown in the network view. The reader is interested in learning more about using software to help why qualitative coding should refer to software. Now I go back to the previous slide, and here we have dummy coding, yes, structured qualitative responses. The previous one was unstructured, now about structured. Qualitative responses to structured questions are like yes or no can be stored in data files with letters Y and N, can be represented with numbers. One each represents the respective category. Number 1 can be used to represent yes, and number 2 can be used to represent no. This represents a nominal numbering system, and the actual number used are arbitrary. Even though the codes are numeric, the variables are classificatory and simply separating the positive from the negative responses. But the research may consider adopting dummy coding for this type of responses, yes or no. Dummy coding assigns a 0 to one category and 1 to the other. So for yes-no responses, 0 could be no and 1 could be yes. 0 could represent a female respondent and 1 would be a male respondent. There are frequently benefits of analyzing in this benefits in the analytical stage as well of using numeric dummy code, as they provide the researcher with more flexibility in statistical techniques. And dummy coding can be used when more than 2 categories exist, but because a dummy variable can only represent 2 categories, multiple dummy variables are needed to represent a single qualitative response that can take on more than 2 categories. So in fact, the rule is that if k is the number of categories for the qualitative variable, k minus 1 dummy variables are needed to represent the variable. This was discussed with the wine. Now, data file terminology. Once structured qualitative responses are coded, they are stored in an electronic data file. And both the qualitative responses and the quantitative responses are likely stored for every respondent involved in a survey or an interview. And the terminology exists that helps describe the process and the files that result. And the researchers organize coded data into cards, fields, records, and files. Cards are the collection of records that make up a file. A field is a collection of characters. A character is a single number, letter, or a special symbol, such as a question mark, that represents a single piece of data, usually a variable. Some variables may require a large field, particularly for text data. Other variables may require a field of only one character. The variables are represented by string characters, which in computer terminology for a series of alphabetic characters, non-numeric characters, that may form a word. String characters often contain long fields of 8 or more characters. And in contrast, a dummy variable is a numeric variable that needs only one character to form the field. And generally, a field forms the column of a data set. A record is a collection of related fields. A record was the way a single complete computer card was represented. And researchers may use the term record to refer to one respondent data. And generally, a record forms the row of a data set. A data file is a collection of related records that make up a set. Value labels are extremely useful and allow a word or short phrases to be associated with a numeric coding. This exhibit shows the SPSS variable view used to describe the data in a file. Most of the headings are straightforward, beginning with the name of the variable, the type of the variable, the size, the label, and so forth. Toward the bottom, that variable country is a string variable, and the values for these variables are words that correspond to the country from which that specific records originate: Austria, Brazil, Canada, and so on. And all of the remaining variables are numeric. Often a researcher will create a second numeric variable to represent the string variables, 1 for Australia, 2 for Brazil, 3 for Canada, and so on. The coder will sometimes like to associate a label with specific value of numeric variables. As here, how a data file is stored in SPSS. Data are generally stored in a matrix that resemble a common spreadsheet file. And a data file stores the data from a research project, and it's typically represented in a rectangular arrangement, a matrix of data and row in a column. And usually each row represents a respondent's scores on each variable, and each row represents a variable for which there is a value for every respondent. And here we can see in this the data matrix corresponding to the variables from the previous slide. And a spreadsheet like Excel is a good way to store data, and statistical programs like SPSS and SIS and other can easily work with Excel spreadsheets that we see here. Now, this is another example, building a multipetabyte data system. What is a petabyte? Well, if you are familiar with disk storage and computers, this storage is measured in gigabytes, GB, and a petabyte is 1 million GBs. Who would possibly need such a large data system? For sure, big corporations like Walmart, with over 800 million transactions and over 30 million customers each day, the data coding and analysis needs for such systems are pretty obvious. And a reliable and flexible data system design is crucial to meet Walmart's substantial data requirements. whether it is the supplier who wish to view product movements and sales, and who are interested in business intelligence. Yeah, it's the key to success. But over time, as the demand for richer and more robust and timely data analysis is increasing, Walmart appears to have made the investment needed to grow their data warehouses. So for sure in the future, we are going to have this data mart, smaller subject-specific data system that can handle the need of these particular business areas. Now the next topic is about code construction. There are two basic rules for code construction. The coding category should be totally exhaustive, meaning that the coding category should exist for all the possible responses. With the categorical variables, making categories exhausting is not a problem. When trouble may arise when the response represents a small number of subjects, or when responses might be categorized into a class not typically found. Missing data should also be represented with a code. Like in the old days with computer cards, a numerical value that was out of range of the actual values was used to represent missing data and maintained to correct the space in different columns. Second, the coding category should be mutually exclusive, independent. It means that there should be no overlap among the categories to make sure that the subject or the response can be placed in only one category. Task tabulation is the tallying of a small sample of the total number of replies to a particular question, and the purpose is to preliminarily identify the stability and the distribution of answers that will determine the coding scheme. Devising the coding scheme. A coding scheme should not be too elaborate, and the coder's task is only to summarize the data. A preliminary scheme with too many categories can always be collapsed or reduced later in the analysis. If the initial coding is too abstract and only a few categories are established, revising the code to more concrete schemes will be difficult unless the raw data were recorded. Codebook. A codebook gives each variable in the study and its location in the data matrix. The codebook provides a quick summary that is particularly useful when data files becomes very large. Coding data on the go. Collecting business critical data takes time, and often data collection specialists and researchers must stop their organizational responsibility to code a data value in a spreadsheet or a business database, and this can take valuable and productive time away from their other responsibilities. This company, Vanguard AccuSpeech and mobile voice platform, is a mobile enterprise system that uses cell phones technology and proprietary voice recognition software to execute voice commands, to store, to code, or to record data hands-free. That is really helpful for all the businesses. Computerized survey data processing. While a very simple study may use hand tabulation, virtually all business research studies with large sample size use a computer for data processing. The process of transferring data from a research project, such as answers to a survey questionnaire, to computers is referred to data entry. Several alternative means exist for entering data into a computer. In studies involving highly structured paper and pencil questionnaire, an optical scanning system may be used to read materials directly into the computer's memory from mark-sense questionnaires, similar to the form used for multiple guess exams. So, like in the previous example with coding data on the go, even mobile phone technology is now being used to help the data processing.